So we have 3x squared plus 4 root 3 xy minus y squared is equal to 7. So what's key is we want to eliminate the product part. So from this, we identify our a. So we're saying our a is always the coefficient of x squared, so that is 3. B is the coefficient of the product xy, so which is 4 root 3. C is the coefficient of y squared, which is minus 1. So we can use tan 2 theta here. Which is going to give us what? What are we getting? B, which
it's
is
going to be 4 root 3 over 3 plus 1.
yeah, so 4 root 3 over 4, which is root 3. So that's tan 2 theta. Meaning that, what's our 2 theta?
It will be the tan inverse.
Tan inverse of root 3, which is which angle now?
It's 54.74.
Huh?
It's 54.74. Oh, no. It's actually 60, not 54, it's 60.
Yes. So this means that 2 theta is equal to 60. And so what is theta?
Theta is 30.
80. So when we go to our x, so we have x now equal to x prime cos 30 minus y prime sin 30, which is what? What is cos 30? And sin 30, is it? You are doing this one.
Yes.
So
No,
then,
I'm trying to remember the special angles.
okay. So here we have this cos 30, which is half x prime plus root 3 over 2 y prime. So that means that we can now get rid of the product. So we start by first calculating what x squared is, which is just x times itself, is it? So we'll have root 3. What we can do is, let me just write. Let's write this in this way. So you see that we have a 2 down that's common, is it? So
yes,
we'll factor out the 2 and then square it, so it will become 1 over 4. And then we'll remain with root 3 x prime minus y prime multiplied by root 3 x prime minus y prime. Then we expand this. So it will be 1 over 4 3x prime squared minus 2 root 3 x prime y prime, and then plus y prime squared. So I've multiplied this by that and added to this by that. for us to get the 2. Okay. Then we can get also 4 root 3 xy. So that would be 4 root 3. From x and y, again, we have a half. That's common. So when you factor out from both, it will come out as 1/4. And then we'll remain with x prime. We remain with root 3 x prime minus y prime multiplied by x prime plus root 3 y prime. So the 4s will take care of each other. So remain with the root 3 outside. And then root 3 by x there. So we'll have root 3 x prime squared. Then root 3 by root 3, that will be plus 3 x prime y prime. And then minus x prime y prime. And then minus root 3 y prime squared. Okay. Then we do the y squared. Y squared also, we pull out half as 1/4 since we are squaring it. Then we remain with x prime plus root 3 y prime, x prime plus root 3 y prime, which is 1/4 x prime squared plus 2 root 3 x prime y prime plus 3y prime squared. Okay, so now the remaining job is to put all those things together. Okay, so now we put this together. We now multiply x by 3. We want this. And then add to that. Then minus that. And then we equate. So let's do that. So when we do 3, the 3 here, which will be 3 there. When we do then the other one we did already. Okay. So we so now what we are doing is we get this guy as we expand it. So we'll have 3 by 3 inside. That will be 9 x prime squared over 4. So I'll get then I'll come down and get the x prime from down. From this product, I want to get this part. So I'll say plus root 3 times root 3 will give us 3 x prime squared. And then from the down one also, it's coming as a minus. So get minus x prime squared over 4. So I'm done with the x primes, with the x prime squared. Then we go to the products, the mid ones. So we have minus 3 by 2, that's 6, root 3 over 4, x prime y prime. And then from the mid one, we are getting 3, that's plus 3, root 3, x prime y prime. There was a minus, which makes it 2. So let me just do this. Root 3 x prime y prime. Okay, then the last one is minus 2 root 3 over 4 x prime y prime. Okay, let's check. Is it true? That one is 3. Yeah, there's no denominator there. Okay. From up it came as 3. Oh, okay, good. Everything is there. And then the y's, so we have plus 3 over 4 y prime squared, and then minus root 3 by root 3, it will be 3y prime squared, and then minus 3 y prime squared over 4 equal to 7. Yeah, like that.
So I have a question. So it's best you first deal with like the x squared and the y squared independently before you put them back in the original equation, like the 3x squared plus 4 root 3xy minus y squared is equal to 7, right?
Yeah, it's best because you avoid making mistakes there when you're multiplying.
Okay.
Because there you're doing shorter lines as compared to now if we are doing all the work in the same line, and you see how it has just become. So I would have a number of these long lines and I'll end up making a mistake somewhere.
Yes.
So now, we simplify. First, you want to make sure that the product is no longer there. That's a very key thing here. So first, for the x prime squared, we have 4 down, and then 9 plus 12, it's 21, minus 1, it's 20. Yeah, so 20 over 4 is 5. So we get 5 x prime squared. We don't want to have x prime y prime. So let's see if we have it. This, we can simplify here. 2 here, 3. 2 there, 2. So we get 3 over 2. Then here, 2 here, 1. 2 there, 2. So when 2 is the common denominator, we'll have 3 root 3 plus 3 root 3 minus
Isn't this one supposed to be 6 root 3?
which one?
The same 3 root 3
Okay, yeah.
x prime y.
This one's supposed to be 6. The middle one, is it? And then minus 4 minus 4 root 3, and then minus root 3. Oh, let's see. There's something happening here. Where did we find this one? What was this one? This guy. We found it where? This came from X. It came from the mid one. So the mid one was giving us 3 root 3 minus root 3 x prime. Okay, so there's no, this guy is not, it's not 2 actually, it's just root 3. Okay, let me remove this, we'll redo it. So here, okay, let's see what happens. So we're saying first the 3 root 3 minus root 3 is going to be 2 root 3, is it? And then this is just a root 3 there. Oh, so this is a minus. So we have minus 3. So if we put 2 down, we'll have minus 3 root 3 plus 4 root 3 and then minus root 3. Yeah. So if we see, if you add these, we're getting a 0 here, is it? So it means that the product has gone. So we're okay. Once the product goes, then we are fine.
We're getting rid of x prime, y prime, right?
Yes.
Okay.
That's the main purpose of doing the rotation. If you do the rotation and then you end up having the same x, y prime, it means that you are wrong.
Okay.
Then then we go to the y primes now. So we have 4 down. So 3. Okay, so these are just canceling each other. This one and that one, is it? So meaning that we're going to have minus 3 y prime squared is equal to 7. So we can transfer this information to another page. We're going to have 5 x prime squared minus 3 y prime squared is equal to 7. So we divide by 7, we divide by 7, we divide by 7, so that we get x prime squared over 7 over 5 minus y prime squared over 7 over 3 is equal to 1. So we need to find C.
Wait, so when we divide by 7, we're trying to make x prime squared and y prime squared have coefficients of 1.
1
Okay,
each.
I get it. Okay.
So so we have that there, and then we find C. So C squared is 7 over 5 plus 7 over 3, which is 15 down. 3 by 7, that's 21. Plus.
We know that this one is a what? Hyperbola or ellipse. Okay, hyperbola, yes.
How do we know?
On the c squared we're adding.
How do we know that
the
it's a hyperbola for us to add? What makes us tell that this is a hyperbola, not ellipse?
mm,
It's a minus, that is it.
on the standard equation for the hyperbola. Oh, okay. Yes.
The minus, is it?
Mm-hmm.
Okay, so we'll have c squared is equal to 21 plus 35 is 56 over 15. Can we simplify? Not so sure.
No.
So c is going to be plus or minus this very root.
Mm-hmm.
Yeah. And then what else do we need? We have our a, the root of 7 over 5. Our b, the root of 7 over 3. So we can sketch. So when you sketch, it's along the x, is it?
Mm-hmm.
So it will be like that. Like this. So where this is minus root 7 over 5, that's positive root 7 over 5. And then this is c, which is minus root 56 over 15. And this is c, which is plus 56 over 15. What else is remaining?
The asymptotes.
Asymptotes, which we find by saying y is equal to plus or minus b over a x, is it?
X. Yes.
So remember, these are primes. So our b is the root of 7 over 3 over the root of 7 over 5 x prime, which we can simplify. It will be 5, it will be root 5 over 3 x prime plus or minus when you simplify. So we have this line. And another line coming from this side. So this is y is equal to minus 5 over 3x prime. And this is y is equal to plus 5 over 3 x prime. And so this, so to avoid any debate, this axis is y prime, this axis is x prime.
Mm-hmm.
Because if you put x and y, it becomes wrong because we haven't taken care of the angle to draw our hyperbola. So we've assumed that the angle is actually that the angle is that we have just rotated it, and then after rotating it, we balance it that way.
Okay.
So, well, whenever you're dealing with a hyperbola, if you want, there's this part of where you can understand the directrix. You know, this guy has got directrix, but this happens mostly in application. This is the equation: x prime is equal to a squared over c. So you would have
That's the equation for the directrix.
for a directrix, yes. So if you are not in rotation, it's just x is equal to a squared over c. If you're in rotation, that's the one. And so those just be straight lines.
Okay.
Yes, if attempted to calculate, you will see that they just be straight lines, and then there will be nothing much there. Okay, so C has 400x squared minus 640 xy plus 256 y squared is equal to 3629. So we want to get tan 2 theta, which is what?
B is 640 minus 640 over 400
minus
256.
what numbers do you get?
Down is 144. So it will be negative 650 over 144. And it's 40 over 9, negative 40 over 9.
Negative 40 over 9. So if you draw triangles, this is going to be 90. And suppose this is our 2 theta. And so this is saying you would get tan is opposed over hypotenuse. So it means that 40 squared, what is 40 squared plus 9 squared?
It's 1,681.
Then get the square root.
It's 41.
41. So it means that we can find cos 2 theta. What is cos 2 theta? From there, adjacent over hypotenuse. And then I want to find cos theta. So cos theta is the square root of 1 minus cos 2 theta over 2. And then sin theta is 1 plus 2 theta over 2. Is it?
So if we got the direct way, we'd get it wrong.
Yeah, because the
Like
direct way, what we are having there, we have cos 2 theta. But our equations, they have cos theta. So we need cos theta,
Okay.
not cos theta. You get that?
Yes.
So we have 1 minus cos 2 theta, 9 over 41 over 2. And the other one, 1 plus 9 over 41 over 2. So this will give us 50 over 41 over 2, which is 25 over 41, which is 5 over root 41. And then this one, 41 minus 9, it will give us what? 32.
It's 32 over 40.
So it will be 32, which is 16. So it will be 16 over 41, which is 4 over root 41. Like that. So now when you go to your x, we are going to have x prime cos theta. So meaning we'll have 4 over root 41 x prime minus sine theta, which is 5 over root 41 y prime. And y, x prime sine theta. So we have 5 over root 41 x prime plus 4 over root 41 y prime. So I'll leave you to do this. So now you finish it up. You have your x and your y. So your job is to bring it here, there, here. And then the product will be cancelled. Then you work out numbers. And after you work out numbers, then you divide by 369. And then you'll see that everything will be coming out until you're able to sketch. Then you can also try, so this is your first task. Then your second one, you do D. The D of the sample. Yeah. D is almost the same as F. So you do D. And then when we meet, we'll see if they are correct. We'll discuss a bit and then do those application questions before we can move to parametric equations. Is that fine? So I said you finish up this. And then
the C.
Yes. Since
And
you are given X and Y, so you just substitute there. Then you do D.
Okay, 11D.
Yes. Which one was it?
Oh,
No,
this
10,
is
10D.
question 10.
Yes.
Okay, 10.
Yes.
Okay, sir. Thank you so much.
All right.